Hi, everybody. So to kick this off, I wanted to just throw it back a little bit to what we talked about in the previous section. So we talked about central angles, and central angles are angles whose vertices are in the center of a circle. So I see that my central angle is 82 degrees. So if I took my sides of the angle and I saw where they intercepted the arc, I would see that I have a nice little arc here that is also 82 degrees. So the central angle and the intercepted arc are congruent to each other. Now, if I took this center, and instead of having it be, sorry, if I took the vertex, instead of having it be on the center of my circle, what if I scooched this vertex back? What do you think happens here versus this little angle, this 82 degrees, and this angle down here? So if I had these lines still go to the edges of that arc, look what happens. Compare this angle right here to this one. Do you see how it gets smaller? It does. So this angle, this one down here, with its vertex on the circle, that is what we call an inscribed angle. And so this section is all about inscribed angles. So again, an inscribed angle is one whose vertex is on the circle. All right, so we already saw a problem that dealt with inscribed angles. We talked about it briefly in class the other day. So here, the problem was from section 9.3, and it talked about AC being a diameter of the circle O, and we knew that one angle was 35 degrees. Remember that we knew that all radii are congruent. So we had a nice little isosceles triangle there. So then if sides, then angles, this guy's also 35 degrees. Now, if I was looking for this leftover angle right here, well, 35 plus 35 is 70. And so 180 minus 70, yeah, 110, awesome. And then if I was interested in what the measurement of angle BOC, measure BOC is, well, I see that 110 and BOC are supplementary. So this guy has to be 70 degrees. And then look blue. We've got a nice little central angle here. My central angle intercepts this arc. And so I know that arc BC is 70 degrees. Sorry for the yellow there. But let's keep that in mind now. So if I look back up here at this angle that is 35 degrees, my inscribed angle, look, if I follow the sides of that angle, this inscribed angle is 35 degrees, and this intercepted arc is 70 degrees. So as we sort of figured out in class the other day, and this is huge, this is the big point of this whole lesson, is if you have an inscribed angle, that inscribed angle is going to be half the measurement of the intercepted arc. So if my inscribed angle is x, my intercepted arc, GO, is going to be 2x. It obviously gets a little bit more complicated, but those are the basics. So let's move forward. Here we go. Snooze. Pause this video, solve for x, solve for y. All right, so you're back. Hopefully you saw I've got a little X here. Its vertex is on the circle, so I know it's an inscribed angle. So I know that it's going to be half that intercepted arc. So X is going to equal 40. Awesome. And then the other side, it's sort of the reverse. So here, my vertex is on the circle. Again, I'm driving that home because we're going to start to get more complicated, obviously. And if I look and see where it intercepts, it is arc Y. So then I know that y is going to be twice 30 degrees. So y is 60 degrees. Again, remember, we're talking about the measurements of the arcs, not the arc length. That's coming later. So let's look here. So I want you to solve for x, y, and then the measurement of arc AC. So pause the video, try it. Okay, we're back. So let's start with x. So if I look at x, its vertex is on the circle, so I know it's an inscribed angle. If I follow the lines of x, I see that it intercepts this arc, that's 40 degrees. So x is going to be half of that, which is 20. So now let's look at y. Well, y is a little funky here. Y is just this. And I don't have intercept, or I don't have any inscribed angle that goes directly just to y, just to that arc. So instead, though, look, I've got another inscribed angle here. So I know then from A to C, arc AC is 100 degrees. So then I know that Y has to be 60. Cool? And then the measure of arc AC is 100 degrees. Excellent. Okay, so a quick little corollary here, and this is actually, I think, one of the coolest things ever. Okay, so if I know that I have a quadrilateral that is inscribed, now remember, inscribed means that all of the vertices are on the circle. So if my quadrilateral is inscribed within the circle, its opposite angles are supplementary, and here's why. So I'm going to call this angle right here angle X. That means that, I'm going to erase that. That means that this intercepted arc is going to be 2x. Cool? Now I'm going to call this inscribed angle angle Y. And if I follow the lines of angle Y, here's an endpoint, here's an endpoint. This arc is going to be 2y. So let's add these guys up and let's see what we get here. So I know that 2x plus 2y, the measurements of those two arcs, have to equal 360 degrees. But then look what that means. That means that x plus y equals 180. What? Isn't that amazing? So the opposite angles in any inscribed quadrilateral within a circle are going to be supplementary to each other. And the same is true for the other two angles that we didn't talk about. So that's an important corollary. And then another little theorem here. So it looks a little different, but essentially an inscribed angle is two chords, right? So we've got two chords and the vertex is on the circle. But this theorem says, well, what if I have a chord and then a tangent? So look what happens. So I'm going to leave this top chord alone, but I'm going to take this bottom one and I'm just going to go and make it a tangent. So that's all I did, right? So remember, if my vertex is on the circle, then I know that the measurement of this angle, I don't know why the color of that tangent changed, but whatever. I know that this angle is still considered an inscribed angle. It might be weird, but it's still considered an inscribed angle. So thus, this intercepted arc, so from the vertex up to the top, that intercepted arc is still going to be twice the measure of that inscribed angle. So if I've got two chords that are inscribed, that's going to be half the measurement of the arc. And if I have a chord and a tangent, that is also going to be half the measurement of the intercepted arc. All right, so let's look at a couple example problems here. So snooze, let's solve for x. I know that x is going to be 40. Awesome. Keep this in mind. I'm going to move ahead. And all I did here was I added on something new. So I still have x being 40 degrees. Here's my intercepted arc. But then I've added in y here. So here's my inscribed angle, and it intercepts this arc. So I've got this little baby arc right here. So this guy is 110. So half of 110 is going to be 55. So I know then that y is 55 degrees. Cool? Keeping this in mind. Awesome. Keep it, keep it, keep it, keep it, keep it, keep it. All right, here comes the next one. So same thing. I still have x is 40. I still have that y is, let's do like a little 55. Same thing. This is the same problem. But now I've added in z. So z, this is sort of like the arc addition postulate, right? Z is going to be this arc plus this arc. It's that inscribed angle because here's the vertex of z. So 110 plus 40 is 150, and then half of 150, is 75. Awesome. So if you break it down and you go sort of in these smaller chunks, these problems aren't that bad. But what if it looked like this? Ah! So in black and white, these problems actually get a little bit more complicated. I know you can do it. You are very smart and you work hard. So let's look at this one quickly before I let you go. So I want to solve for x and y. So a really good trick here is I'm going to first find the one angle that I know. So this is the inscribed angle. If I follow the sides of this angle, I see what arc it inscribes, or what arc it intercepts. So I know that this arc is then going to be 40 degrees right here. Cool, because I've got that inscribed angle. But look, angle X is an inscribed angle as well. And look at the arc that it intercepts. It also intersects that same arc. So I know that X is also going to be 20 degrees. So this is a really important concept. If I have two inscribed angles that end at the same arc, they're going to be congruent to each other. And last thing, let's look at angle Y. So angle Y right here, here is the vertex, and then, here are the endpoints of angle Y. So angle Y intercepts this arc. You know that this guy is 180 degrees. It's a semicircle. So you know that Y has to be 90. And that's another little good side note to think about. So if I have a semicircle, okay, there we go. If I have a semicircle and I have an inscribed angle whose endpoints are on the diameter, and you have to know that this was like circle A, right? So here's my diameter, and if the endpoints of this inscribed angle are on the diameter, this angle is going to be 90 degrees. It does not matter where that angle is. It could even be over here. And if the endpoints are on my diameter, this guy's going to be 90 degrees. All right, so go ahead, try the worksheet, and you're going to crush it. Thanks.